After you've looked at dividing whole numbers by fractions, like we did in the last video, you move into the world of fractions divided by a fraction. And today we're specifically looking at proper fractions divided by unit fractions. And so a proper fraction is just like a regular old fraction with a numerator and a denominator. This is not an improper fraction or a mixed number. All right, so not those. And then a unit fraction is any fraction that has 1 as a numerator. So when we're looking at these today, we'll go with the first example of 2/5 divided by 1/10. I am going to be looking at like what a model would look like for this, what the visualization, the visual way of thinking about it, and then the computational or calculation. So what is always helpful, especially when dividing fractions, is to put into word form, like, what is this problem actually asking you to do for it? It's really beneficial to leverage that language. I mean, we're all language speakers, and so you might as well connect to that as much as possible. So this here is asking, how many 1/10ths can I make from 2/5? And so if you think about this, you know from your model that you have the 2/5. 1, 2, 3, 4. And we have 2 of them. And we need to figure out in there how many tenths is there going to be. So if I grab like a purple, to turn these pieces into tenths, I just need to chop them in half. And I know that each one of these squares here is going to be 1/10. And so I have 1, 2, 3, 4. So 2/5 divided by 1/10 equals 4. Now this can seem a little bit wild because you have a fraction divided by a fraction and you somehow end up with a whole number. But if we think about what this means, how many 1/10ths can I make from 2/5? Well, then it becomes less of a wild thing because you know from the picture that if I have 2 blue 2/5 and I turn them into tenths, I have enough there to make 4/10. So 4 does actually end up being a somewhat reasonable answer. Now, if we wanted to look at the computation for this, looking at the calculation, this is when we use our multiply by the reciprocal. And so that's the code that you need to leave me to tell me this is the thinking that I did. So 2/5 divided by 1/10. We are going to be multiplying 2/5 by the reciprocal of 1/10. And the reciprocal is just the denominator over the numerator. You just flip-flop them. So, and we know from previous lessons on multiplying fractions that we always look for opportunities to simplify first. It's when the numbers are smaller, it's easier to see common factors, and your calculations are just a little bit more accurate. So I know 5 can be divided by 5, and 10 can be divided by 5. So I'm left with 2 and 1. So I am going to rewrite this just so it's a little bit more clear and I can stay accurate. So 2 over 1 times 2 over 1 is the same as 4 because we can just multiply straight across over 1. And our answer is 4. So here we did get the same answer as we did with our model, and so it's nice to back that up both with the calculation or computation and the visual model. Now, there are some times where here, like this fraction, 2/5, is greater than the other fraction. And so there are some problems where, let's say you have what is 1/4 divided by 1/2, or how many halves can I make from 1/4? So if we're doing our model again, I'm going to borrow that. And I would like a different color today. Let's make this one teal. Okay, so if we're going in that direction now, we have 1/4. And we need to see how many halves can we make from there. Well, when I look at this, I know a half of our model is right here, this amount. And so based on what I see here, I can tell that I have 1/2 of what I need in order to get a half. So I have a half of a half. So 1/4 divided by 1/2, we can make 1/2 groups. So it does seem a little bit wild, but if this is what I have, This is the size of my groups. I don't even have enough to make one entire group. I only have enough to make half of a group. So that does seem a little bit wild, but you know what? Here we are. This is the life we live. So if we were to look at the computation for this, and we are going to do multiply by the reciprocal, 1/4 divided by 1/2. We know we are doing 1/4 times the reciprocal. And I am going to simplify this by dividing by 2. And so I am left with 1/2 times 1/1, and that is just 1/2. So our answer checks out, just like we did in the last one. So we do have an interesting observation here that can help us figure out what is going to be a reasonable answer. So these reasonable answers, and this is something I love to think about because it helps keep me accurate. And sorry about the delay while I write. Okay, so reasonable answer. So in our two examples, we had 2/5 divided by 1/10, and then we had 1/4 divided by 1/2. So here we have the greater fraction divided by the smaller fraction, and that meant we got a whole number. Because our first fraction is bigger than the size of our groups, rather, the amount that we have is more than the amount in each. We have enough to make whole groups. But when we have our smaller fraction divided by our greater one, we have less than each group, and so it would make sense that our answer is a fraction. We don't have enough for one whole group. We only have enough for a fraction of a group. So here we can tell in a situation without even doing any calculations, if we compare the value of these numbers, we already know that our answer is going to be a fraction. It's going to be less than 1. So if I get an answer that's greater than 1, like that's going to be an indicator that maybe I did something wrong. Same thing over here. 2/5 divided by 1/10. If I have a greater fraction divided by a smaller fraction, my answer at least needs to be 1 whole, and it could always be a mixed number. So if I get something that's just a fraction, I've done a problem and I got to figure out where I went wrong.